In the previous video, we looked at 3 of the 12 principles of green chemistry. And today we are continuing to look at more using various examples. The previous case study was able to serve across the 3, but as I highlighted, usually it is hard to implement all the 12 in one case study. So today we are going to have different case studies or different innovations in each of the next 3 principles. Designing safer chemicals involves producing products that have no toxic risks. At the end of the day, we want products that are able to serve their function, but now with this principle, we are aiming to reduce the toxicity in the long run, whereby with this principle, we are aiming to get products that have eliminated or reduced significantly the risk of products being toxic. I'll use an example in the paper industry. Back way in 1990s, the bleaching method that was being used at the time was mainly the elemental chlorine, and it was used in that the end goal would be a white paper to remove the different dyes, the different color components in the processed tree tissues. But it came with its side effects. At the end of the day, the waste that came from the bleaching process had furans, had the dioxins, which were really terrible. And in one of our videos with Saleh Sedume Ahmed from Uganda Kenya Production Center, he highlighted that these are part of the dangerous chemicals known as the persistent organic pollutants. So this was a concern at that time. So there was a development to go to at least another better method of bleaching the paper. And that method was element chlorine-free bleaching method. And here, what they're using was chlorine dioxide. So chlorine dioxide was being used to bleach paper. It had its effects, but it had decreased or reduced the amount of the persistent organic pollutants that were going into the environment. Of late, there is a new trend that is happening in bleaching that is picking up, whereby hydrogen peroxide is used to bleach. Here we are seeing that it is one of the best environmentally friendly method of bleaching. Hydrogen peroxide degrades into oxygen and water. So these are naturally occurring compounds with no effects. So we are seeing that it took the paper industry to reach this far. So in this principle, we are saying that we are designing at the end of the day to serve the purpose, which is at this point bleaching, but at the end of the day, it is safe, whereby the ideal is hydrogen peroxide and it is eco-friendly. However much, this should be a caution that research and development should always continue to make the alternatives as good as the substituted compounds. For example, if someone wants a very clear paper, it will be harder for hydrogen peroxide to yield that, but still the paper quality will be good. So this is also calls for advocacy in the mindset whereby the consumers, us, we are able to be accommodative as the process is being refined to get us where we want. By the end of the day, we have a safer planet and we have a paper onto which we'll write. A raw material or a feedstock should be renewable whenever it is technically and economically feasible. The reason is that it will be able to be regenerated over and over again, in that we are not depleting those resources which in the long run will not have them because we have overstrained their supply. This principle also addresses the energy sources. It advises that the energy sources should be from renewable feedstock. For example, biomass, solar energy, hydropower, and many other forms. So we are saying that the holistic view of this should be that the renewable feedstocks are being used in that we avoid the depletion of the natural non-renewable resources. To give an example about renewable feedstock, in Brazil, since sugarcane is one of the biggest sector in that country, a lot of alcohol or ethanol particularly is processed, but due to the inability to consume it, it is processed into bioethanol. Now, bioethanol can be used to blend fossil fuels. The use of blended fuel reduces on the carbon emission. This is because if they're coming from a renewable source, say plants, since plants use the carbon dioxide in the air compared to the fossil fuels that only add it, in the long run, we'll be able to absorb more carbon dioxide using the renewable energy because the source from which they come utilizes the carbon dioxide being emitted. To add on this, we are also seeing an American company called NatureWorks that produces a plastic called polylactic acid. And in this, the plastic being talked about in this regard under industrial conditions can degrade or can compost compared to the different plastics that cannot degrade, that are non-biodegradable. With such a product, it is easier to reuse, to utilize this product, and it is safe for the environment. Now, someone might ask, where is lactic acid gotten from? Lactic acid is obtained from the fermentation of dextrose that is obtained from starch, which normally people call it corn. Designing for degradation. This principle helps the product researchers, product developers, and chemists in that whenever they are designing a product, they are thinking about the end. Where will it be put? Where will it be at the end of life, at the end of use? So this principle helps us to think beyond the life of usage. At the end of the day, researchers are going to come up with products. For example, I've talked about the polylactic acid that can be broken down back to its form that can be used as raw materials, hence recycling. With this principle, there will not be accumulation of non-biodegradable products at the end of the day, whereby we will see that landfills are filled with plastics that cannot be broken down. So with such products, where the developers, where the chemists thought about their end of life, they are easy down at their end of life to be recycled, to be reused, or to degrade into substance that can be worked on. Another example is the bleaching process I talked about previously, where they're using hydrogen peroxide. We are seeing at the end of the usage of hydrogen peroxide, it will break down into water and oxygen. So these are naturally occurring compounds without any effect to the environment. So with such a principle, we are eliminating the effect of the accumulation of toxic compounds in the environment. So in case you enjoyed these three, please subscribe and you'll get notification when the next 3 of the 12 principles of green chemistry will be posted. Thank you for watching. Bye.